Lesson 3.4, Video 2. Here we're going to look at an example and describe or interpret this graph. Now if you look closely at the graph or the equation given, this is a absolute value function, but it has had things done to it. We have a negative sign there, we add a 1 there, and we add a 3 there. So this graph, this function, has been transformed. So what does it look like after that transformation? Now if you remember, the original function looked like that, where you had the v, bottom part of the v on the origin, and it took off in straight lines upward in either direction. This one obviously is much different. It opens downward for 1, and the v part is not at the origin anymore. So let's take a look and see what we can observe. If we start with maximum, we're going to definitely look at this point right here. Now this point is a coordinate, and it is a coordinate -1, 3. It's important to understand what this means. It means that the maximum occurred at -1. Okay? But 3 is the actual maximum. Okay, so it occurred at -1, and the actual maximum is actually 3. So that's how we want to interpret this. So when they say state the maximum, we would say it is 3. The minimum, however, well, these lines go on forever in both directions, downward. Okay? That means that it will never stop. If you expand the graph, the line's still there, it just keeps getting smaller and smaller. So this one actually has no minimum, or none. Alright, so let's estimate the zeros. Now we talked about this as well. Zeros are also called x-intercepts. They're also called roots and solutions, but in this particular case, x-intercepts make the most sense. So if you look at the graph, we have an intercept right there and an intercept right there. So our x-intercepts are at -4 and at 2. So this is not a coordinate, this is an observation that our graph crosses the x-axis at -4 and at 2. So those are the zeros. I'm going to stay on this page, but I'm going to address the next question, which is state the intervals where the function is increasing and decreasing. Now the red line is our function. I'm going to focus on this a little bit closer here. So we're asking ourselves, and we're going to talk about this going left to right. So as we go left to right on the x-axis this way, our graph is going up, 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 up. Okay? Now it goes up, up, up until you hit this point right here. So our graph is increasing from -infinity, which is way, way left, up to -1, and then it stops. And then from that point on, continuing on to the right, our graph starts to go down, 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 down. So decreasing. So our graph is decreasing from -1 to +infinity. And you can write a plus in front of there if you'd like to. And this is how we'd write our answer. We would say from -infinity, arrow, -1, it is increasing. And from -1, arrow, or going towards +infinity, it is decreasing. And this ends lesson 3.4, video 2.